Good afternoon, my YouTube viewers. It's Crystal here. I'm just here this afternoon because I want to do an exploratory data analysis on an asteroid dataset. And the reason why is because I was taking a course on YouTube for data analysis, and the last part of the course is you had to do a project. So I found this asteroid data set and I thought that would be a good thing to do a project on. So the first part of this code review is just telling you what the different features mean. But since I'm not actually into astronomy that much, I don't know that much about astronomy, I can't tell you a lot about what each feature means. And so, but it's there. If you know about astronomy and you know what each feature means, then it's there. And what I did was I actually wrote this program in Google Colab. And so Google Colab is a great platform to use if you're working in data science, and it's free. You don't have to pay for it, and it's hosted by Google. It's a Jupyter notebook that's hosted by Google. So when we wrote the program, the first thing that we did was we imported the libraries. And so the libraries that I used in this instance were Pandas, NumPy, Matplotlib, and Seaborn. So Pandas is a library that's used to create and manage data frames. NumPy is a library that carries out numerical calculations. Matplotlib is a library that plots data points onto a graph, and Seaborn is a more sophisticated library built on top of Matplotlib that'll do more sophisticated graphs. So after we have loaded the data set, loaded the libraries, then what we need to do is we need to actually load the data set. And so you can see I'm using Pandas to read the CSV file, and I've got this data set from a GitHub account, and so you've got the code for the GitHub account right there, so you can use that data set if you want to. It's also on Kaggle as well if you want to use it on Kaggle, but I prefer to get things off of GitHub because it's saved in a GitHub repository, whereas on Kaggle you would have to download it, and then I would have to download it onto my computer, and I don't want to use all of the memory in my computer downloading data sets. So if I was going to use a Kaggle data set, I would actually use the data set and the Kaggle website and not my own computer memory. So you can see that we have we've loaded the data set and we've read it in, and what I've done is I've made it so you can see all of the columns, and a column is also called a feature. And I don't know what all of these features mean, but if you know about astronomy, you might know what the features mean. So what we've done is I used the info function to find out some information about this data frame, and so you can see that it's a combination of object and float columns. Then I used the describe function. So what the describe function does is it tells you about the numeric columns, gives you the count, the mean, the standard, the minimum, the 25 percentile, 50 percentile, 75 percentile, and the max. So it gives you all that information. And what I would like to say is on the info, there are 958,524 rows. So you have one row for every asteroid. And since you have one row for every asteroid, you know, it's close to a million asteroids on that data set. And then what we want to do is we want to check for null values. And so we've got an awful lot of null values. And generally when you're working in data science, you're just supposed to delete the null values. And I tried to delete the null values. And whenever I deleted all the null values, I didn't have a data frame left. So what I decided to do was I decided to delete the prefix, because the prefix doesn't have anything in it at all. You can see there are 958,506 null values on the prefix column. And if we come back here, 958,524. So there's only like 18 of those rows where actually there is something on the prefix. So I decided that since there are so many null values in the prefix column, the best thing to do was to drop the prefix. So that's what I did, was I dropped the prefix. And whenever I dropped the prefix, I had still had 958,524, but I had one less column. I originally had 45 columns, now I only have 44 columns. And then after I dropped the prefix, because the prefix had most of the null values of that entire column, there were only about 18 rows that actually had a prefix on it. So I dropped that, and then that sort of like helped eliminate a lot of the null values. And then so what I did was I dropped all the null values. And when I dropped all the null values, we were left with a data frame of over 15,000 rows, which is, so basically of this over 15,000 rows, you see that every single row has data entered in it. So you can see it had 15,069 rows, and that's a lot less than 958,000 rows. I checked for null values after I dropped all the null values, and I got a 0. And then I looked at my length, and it was 15,069, which was just a fraction of the 958,000. So now what we do is we're going to analyze the class. So if you wanted to make predictions on this data set, you could make predictions on this data set, but I just decided that since this is an exploratory data analysis, I wasn't going to make any predictions on it. So here's I did a his plot on the class. So here you can see all the different classes that are available, and MBA is the class that's got the most information. So one thing that you would say about this data set or data frame is that it has a class imbalance, because MBA has most of the classes, and then you've got a OBM, MCA, AMO, IMB, TJN, APO, HEE, CEN, AST, and TNO. Those are all of your classes. So you have a very serious class imbalance here. So, and then what we've done is I did a group by with the class and the name, and it gave me the classes. It gave me the classes and how many of each class you had. So like on AST you only had 1, and TNO you only had 2. So we did a group by on that, and then again we did another length. 15,069 is the length of the data frame. Now we're going to analyze the orbit ID. So if you analyze the orbit ID, it would just tell you what all you got there, and then that's a 208 rows of information. But that's just, if I wanted to, I could actually see what happens. I don't think that's going to work very well. Let's see what happens. Seaborn has no, see what we've got here. SNS is plot. Didn't do that right. So it did a keyboard interrupt. Let's try it once more. So that's your orbit ID if you want to see what the orbit ID looks like. So now what I've done is I've analyzed the diameter and I put that on a violin plot so you can see what the diameter is. So most of the asteroids aren't very big. And then, so what I did was I did an argmax to find the index value of the largest asteroid, and the index value of the largest asteroid is 0 because remember that the first number in Python is a 0, and then I asked to print that off, and so this is a printout of the largest asteroid, which is series. And then we did an argmin to find the smallest asteroid, and that's an index value 14430. And so I printed that off. So this is your smallest asteroid, and its name is Apophis. It's the smallest asteroid. And then what I did was I used some statistics. So I found the mean of the diameter, which is 13.24. The min is 0.34. The max is 939.4. And the mode, the most frequently used diameter, is 3.791. So now we're going to analyze RMS. I believe RMS means root mean squared. I'm not sure exactly why they use it for astronomy, but they do. But I made a violin plot so you can see what RMS looks like on the violin plot. So I used argmax to find the maximum RMS, which is in index number 14690. And so we print that off, and the name of that asteroid is Renako. And then we used RMID to find the smallest RMS, and that is 437. And the name of that asteroid is Abnoba. And then what we did was we used some statistical functions to find out some statistics. So the mean of the RMS is 0.49, the minimum RMS is 0.27, the maximum RMS is 0.71, and the mode, which is the most frequently used one, is 0.44134. So now I've made some scatter plots. I made a scatter plot on the diameter and the epoch so you can see what that looks like. And then I made a scatter plot on RMS and epoch so you can see what that looks like. And then I made a scatter plot on RMS and diameter, and you can see what that looks like. So basically what I've done is I've done an exploratory data analysis on this data set, even though I don't know that much about astronomy myself. So somebody who knows more about astronomy would be able to use more features, and conduct a more in-depth analysis because they know what all the features mean, and they would be able to put that into their analysis. But I think that for someone who doesn't know very much about astronomy, I did, some basics, RMS, epoch, and diameter. And so that'll give you a rough idea of how to do an exploratory data analysis. So I hope you like this code review. I intend on making more code reviews in the future. So if you like this video, please like, subscribe, and share. And thank you so much for supporting my channel.